Now to start this project, I'm going to gather a couple of materials. A container, 2 soap pumps, a syringe, and some tubing. I'd also need some tools such as an X-Acto knife and a glue gun. I also end up using a saw and a drill, but with enough perseverance, I'd assume they wouldn't be necessary. I started by cutting off the valves from one of the soap pumps. I decided against using the knife and used the saw instead for the sake of time. Upon removing the valve, I took out the small bead that was within and saved it for later. Because I had used a saw, I ended up needing to sand down the edges of the valve. If I had used an X-Acto knife instead, I probably would have been able to skip this step. I set it aside and began to cut off the valve from the other soap pump. Once again, I removed the small bead inside and placed it along with the other one inside of a tape roll to store it. I took off the connector tube and placed it alongside the first valve. Using my drill, I drilled a small hole into the side of the first valve. I then attached it to the syringe and made sure that it fit nicely. I then glued it on with my hot glue gun. I placed a bead back inside the first valve. It doesn't matter which one, they're both the same. I then centered the second valve on top of the first, preparing to glue it on. I used my hot glue gun to glue it on and used its tip to form the glue into the desired shape. I set it down on the table and began to drill 2 output holes in the top valve. Then I glued closed the top valve after having placed the second bead inside. As you can see here, it makes quite a nice water pump. I got my tubing and I attached it to the input end of my pump. Then I cut the tubing to the desired length. I began drilling a hole in the container for the tube. I made a bit of a mistake, but then I cleaned it up using the X-Acto knife. I inserted the tube into the container. And then I glued it on using my hot glue gun. I patched the slight mistake I had made earlier. Then I tested it to see how much pressure it could hold and if it worked. It collapsed fairly quickly, so then I spent the next little while trying to come up with a fix for it. I added a little bit of a supporting ring. It seemed to work. Well, it worked up to a point. I put a marshmallow inside to see what would happen. Put a weight on top so it wouldn't move around. As I pumped the air out, the marshmallow barely just increased in size, but not by much. The change is more noticeable in real life than on camera, but it's still visible. Here it is again, sped up by a little. But why does this happen? The marshmallow is made up of many tiny bubbles, and each bubble is under a certain set of forces. Within each bubble, under normal circumstances, collisions between air molecules and its outer wall create many small outward forces. These forces are counteracted by the forces of air molecules outside of the bubble and from neighboring bubbles. Thus, the pressure is normal and the forces are equal. When placed inside the vacuum chamber, there are still the same forces being exerted on the inside of the bubble. However, on the outside of the bubble, this causes the bubble to expand until the forces outside and inside are equal, or until it bursts. I decided to make another vacuum chamber using a better container to get better footage of the marshmallow expanding. Here's a closer up view, and sped up a little bit. Even my new container ended up collapsing after a while. I started off by getting myself a container. I got some pencil leads, 2 small test tubes, I got some alligator clip wires, and I got a battery. I got a glue gun and a couple of extra glue sticks for it. I got a dowel and a knife. I started by using my knife to poke 2 holes for the pencil leads in the container. I then inserted one of the pencil leads, and I glued it on using my hot glue gun. I glued on the second pencil lead. I then began cutting the dowel into pieces to support my container. I made a total of 4. I glued them on around the base of the container using my hot glue gun. This way, the pencil leads are protected when flipped right side up. Then, I filled the container with water. I connected alligator clips to the pencil leads. I got my power source and I attached it to the alligator clips. Now at this point, I could see small bubbles forming on the pencil leads. However, the camera could not see them. So, I went and got every single power source that I could find. I got enough to create a high enough voltage to overcome the great resistance of all the water. Bad news! I broke the entire thing while trying to clean the glass. Yay! So I fixed it, and I came back the next day with new materials to continue the project. Hey, guess what? It works. See that? That's hydrogen bubbling from the cathode, and if you look closely, you'll see oxygen bubbling up from the anode on the left. Now, how does this work exactly? This is a simple diagram of what is going on. You have the anode, which is the electrode on the left, and the cathode, which is the electrode on the right. They're connected to a power source, which is my long string of batteries. The anode becomes positively charged, and the cathode becomes negative. When electricity is passed through water, it is split into 2 ions. It immediately creates one positive hydrogen ion, which I've drawn on the left here, and it creates one hydroxide ion, which is negative, which I have drawn on the right. They gain electrons to become normal hydrogen atoms and then pair up to form hydrogen molecules. Then they bubble up to the surface. Hydroxide ions are attracted to the anode because of the anode's positive charge and the hydroxide ion's negative charge. The oxygen atoms pair up to form neutral molecular oxygen molecules. Then they bubble up to the surface. The hydrogen atoms lose electrons to become positive hydrogen ions. By filling the test tubes with water and inverting them and then placing them on top of the electrodes, the gases can be captured. I set them down at an angle so that there would be more space for ions to flow through the water. I attached the power and bubbles began flowing from both electrodes, though not as much as before because there was much more resistance. I decided to support the test tubes using a glue stick that I found around. This seemed to work quite a bit better as there was much more room for the ions to flow. Gathered at the top of the test tube. If I had let it sit for long enough, it would be possible to test the gases because there would be enough, but with the two bubbles that I had, it would be nearly impossible,